So now that we've learned a bunch of basic digital modules, we've learned how to create full adders, half adders, ripple carry adders to add lots of different bits together. We have different types of decoders. We have comparators. We have muxes. That's quite a toolbox of components. So now we can actually start making some interesting designs. So I'd like to work out a design problem for you that uses some of these components. So let's look at our textbook. Chapter 20 design problems. We'll do design problem number 1. Design a circuit that outputs one 8-bit value. If the sum of the circuit's two 8-bit inputs, A and B, generate a carryout and are equal, the value of 2A is output. Otherwise, the sum of 2B is output. Consider the output value to be an 8-bit number also. Don't worry about carryouts on the output operations. Okay, so there's a lot going on here. We first need to figure out what is our overall black box going to look like. So it's got two 8-bit inputs, A and B, an 8-bit output, and looks like that's all it is. So our big box is going to be A and B as the inputs, and it's going to have one 8-bit output. I don't think it gave us a name for it, so we can give it any name we want. I'll call it F. Alright, and we'll give our box a name. We'll call it DP1 for design problem 1. Alright, so what kind of components are we going to have inside here? Well, we need to be able to compare the value. So it says here, if the sum of the circuit's 2-bit inputs A and B generate a carryout and are equal, the value of 2A is output. Alright, so we're going to need some kind of adder to add together A and B. Then we're going to need some kind of comparator for the output of that. Then we also need to get the value of 2A, so we're going to need an adder for that to add A plus A. And we're also going to need an adder to get B plus B. So I see that we're going to need at least 3 adders, 3 8-bit adders. We're going to need a comparator, and we're going to need some kind of mux to select which output gets out to the output. So I'm just going to go ahead and draw those in. Worry about connecting things later. Alright, so we're going to have 3 adders. Let's see. Oh, maybe I'll draw them like this. One here, one here, and one here. This will be RCA. We can call this R1, RCA R2, RCA R3, and recall that we have A and B inputs to these, and we have the sum and the C out values. I'm going to write it as S and C here because my pen doesn't let me write small. Okay, so we've got our RCA blocks. We're also going to need a compare module. And the ones that we've developed so far are going to be, we have the AB, and then we have the less than, greater than, equal to. And this component can have the name C1. And then we're going to need some kind of mux to get to the output. So we'll just call this thing mux x0, x1. It's going to have some selector input. We could call this mu1. Alright, so now let's try to figure out how we're going to hook all of this stuff up. So if the sum of the circuit's two 8-bit inputs A and B generate a carry and are equal. Alright, so we need to sum A and B. And we need to determine if they are equal. So I'm going to go ahead and get A to go down to here as well. So if it generates a carry and they're equal, so we've got if it generates a carry and it's equal, I'm going to go through an AND gate. Alright, so if it generates a carry and is equal, the value 2A is output. So if they're equal, that means that the output of this is going to be a 1, which means that this can be our select signal here. I'm going to draw it around this way. Let's erase this here. That's not connected right now. Okay, so if it is equal, we want the value on the 1 input to be 2A. So how are we going to get 2A? We can go ahead now and put A into this RCA. Put it into both inputs, so it's A plus A to give us 2A. The sum will be our 2A, and that can now go to X1, because if we get the carry and it's equal, the select will be 1, and therefore we'll select 2A. Otherwise, we want to select 2B. So B, we're going to use this guy, and the sum is going to go into X0. Then the output is going to go to our output F. And there you go. We used only standard digital modules in our design, and we were able to implement this whole design.